This is section 8.3, the inverse of a square matrix. And we will spend only one day on this lesson. Before we talk about inverse matrices, we need to talk first about the identity matrix. Right? What is the identity matrix? If I have a matrix A, for example, this matrix, -2, 3, 1, 0, 1, -2, -1, 10, 6, I can multiply it by another matrix I, and I stands for identity, and you'll see why in a second. And the I matrix is 1, 0, 0, 0, 1, 0, 0, 0, 1. You can see that looks like what you get when you do Gauss-Jordan elimination on a matrix. It looks like the left-hand part of that matrix. Ones on the diagonals, and zeros everywhere else. Well, this is called the identity matrix because it's the multiplicative identity. Recall from Algebra 1 that the multiplicative identity is the number 1. Because anything times 1 is itself. Anything times 1 is itself. 8 times 1 is 8. 9 times 1 is 9. 10 times 1 is 10, etc. Well, with matrices, the multiplicative identity is the matrix I. The matrix I, which has the same dimensions as the given matrix, matrix A in this case. Same dimensions. It's also a 3 by 3, but it has ones on the diagonal and zeros everywhere else. And when you do this multiplication, I'd like you actually to pause the video, do the multiplication AI, and see what you get, and then resume when you have an answer. You can use your calculator. And you end up with the product matrix AI equals -2, 3, 1, 0, 1, -2, -1, 10, 6. So we can see that we end up with simply the original matrix A. Alright, so that's the identity matrix. For the identity matrix, A times I equals A, and that equals I times A. Matrix multiplication is commutative for the identity matrix because it has the same dimensions. We're always talking about matrices that are square. An inverse matrix undoes a matrix such that A times A inverse, by the way, that -1 shouldn't confuse you, looks like something to the -1 power, but that's not what it means. It's just a symbol, and it's a symbol for the inverse matrix. So A times A inverse equals I, and that equals A inverse times A. So this matrix multiplication is also commutative. Now let's see how the inverse matrix works. If I have A 1, -1, 0, 1, 0, -1, 6, -2, -3, and I'm given A inverse, which is -2, -3, 1, -3, -3, 1, -2, -4, 1. And I multiply A by A inverse, what do I get? Well, pause the video, do that on your own. You can use your calculator if you want, and see what you end up with. Then resume. You should have ended up with this product matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1, and as you can see, that is simply the identity. That's the identity 3 by 3 matrix. Now, since matrix multiplication is commutative for square matrices, the same is also true for A inverse times A. The matrix A inverse times the matrix A, and that equals the same identity. 1, 0, 0, 0, 1, 0, 0, 0, 1. Finding the inverse of a square matrix. How do we do this? Well, it's actually a pretty simple method, and the good news for you is that the best way to do it is on your calculator. Just be careful about how you enter in the data. Make sure you always enter in your data correctly. But you can use your calculator for these steps. All right, so let's say that you're given the matrix A, 1, negative 1, 0, 1, 0, negative 1, 6, negative 2, negative 3. And you want to find the inverse. Well, what you first do is augment matrix A with the identity matrix. Augment matrix A with the identity matrix. What does that mean exactly? It just means that right next to, on the right of matrix A, in a larger matrix, you simply write the identity, the 3 by 3 identity, which is 1, 0, 0, 0, 1, 0, 0, 0, 1. And so what we end up with is this augmented matrix of order 3 by 6, of order 3 by 6. Then you're going to use this augmented matrix. You're going to use this augmented matrix to perform Gauss-Jordan elimination on your calculator. Remember, you're going to use the row reduce or RREF function of your calculator. And what you'll end up with is the identity and negative 2, negative 3, 1, negative 3, negative 3, 1, negative 2, negative 4, 1. All right, so definitely prove that to yourself by doing this on your calculator. Make sure you end up with the same result. But this result that's shown here, where I'm seeing a 3 by 6 matrix with the identity on the left half and another matrix on the right half, this actually yields the inverse because the right half is A inverse. The right half of this augmented matrix, which is the result of what I did in my calculator, is A inverse. And A inverse is negative 2, negative 3, 1, negative 3, negative 3, 1, negative 2, negative 4, 1. Now, only square matrices are invertible, but not all. Okay, so if a matrix is square, it might have an inverse, or it might not. If a matrix is not square, it definitely does not have an inverse. Okay, so only square matrices are invertible. Only square matrices can have inverses. But not all square matrices can have inverses. And a non-invertible square matrix is called singular. Singular. Now on the next screen we're going to see how to find out whether a matrix has an inverse or not. But for now you should make sure that you write this down and understand it. Only square matrices are invertible, but not all. A non-invertible square matrix is called singular. Now the inverse, or I'm sorry, the matrix A, the matrix A given here on the upper left portion of the screen, that matrix A is invertible because it has an inverse, and therefore it would not be called singular. So a singular square matrix, a non-invertible square matrix. Let's say we're given the matrix A, 1, 2, 0, 3, negative 1, 2, negative 2, 3, negative 2. And we want to first find out whether it has an inverse. And if it does, we want to find out, well, what is that inverse? And the good news here is that you can actually find out both things in the same step. So you kill two birds with one stone. We simply augment matrix A with identity matrix. And I'm going to get the augmented matrix 1, 2, 0, 1, 0, 0, 3, negative 1, 2, 0, 1, 0, negative 2, 3, negative 2, 0, 0, 1. That's my augmented matrix A. Then I'm going to use this augmented matrix to perform Gauss-Jordan elimination on the calculator. And you should pause the video, do that on your own, and see what you get, then resume. And you should have ended up with this 1 0 4 7 0 3 7 1 7 0 1 negative 2 7 0 2 7 3 7 0 0 0 1 negative 1 negative 1. And of course, your calculator might have given you those fractions as decimals. That's fine. But what we can see here is that when we did row reduction, the Gauss-Jordan elimination, we did not end up with the identity on the left half of this augmented matrix. We ended up with fractions and with a 0 on a diagonal. So what that tells you is that there's no inverse. Okay, so matrix A here, given in the upper left portion of the screen, is a singular square matrix. Since it is impossible to get the identity matrix on the left, this is a singular, non-invertible square matrix. The Classwork, page 608. Please write these numbers down. I think you'll find them fairly easy to do. So you might want to get a head start and have free time in class, or simply wait until class and you'll have enough time to do these problems.